Okay, why is the alcohol secondary and not primary? What's the reasoning behind it?
It's more negative number.
Okay. The secondary carbon has more negativeness around it, so it's better able to stabilize the temporary positive charge. Did we have a name for that positive charge? Do we remember what that was called? A carbon with a plus on it. Carbocation.
Carbocation, that's right. I wrote it down somewhere. Oh, right there.
So you've got more electrons around the secondary carbon than you do a primary carbon. And so it's better able to stabilize the carbocation. And the carbocation is the carbon that has 3 bonds. So it's missing that 4th bond. So something needs to come over and give it 2 electrons. What would Lewis call that? A carbocation would be what kind of something or other? That'd be an acid. Because he's talking about electrons being donated and accepted. That doesn't have any electrons to donate, but it's really interested in accepting some electrons. So as far as acids go, they don't really get much stronger than that. A carbon that is missing a bond is an incredibly powerful acid. Okay. Right at the chemical formatted like an equation above for hydrochloric acid and 2-pentene. Okay, so I got a carbon and a carbon and a carbon and a carbon and a carbon, and it's 2-pentene, so I'll put a double bond right there. And then I'll put hydrogen, 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 plus HCl. Okay. And what do we have for the, what's it going to look like on the other side? We okay with that? Both those carbons are, give me the classification for carbon number 2 and carbon number 3. Say again? They're nearly chemically equivalent, but their classification, they're both secondary. So neither one of them has more electrons around. So does it matter where the chlorine goes? So what are your chances? About 50-50, yeah. So you got about a 50% of each of these things. Circle and label some functional groups. All right, so I got alcohol, I got amine, and I got another amine. And I got an alcohol. What's this one here? Carbon, oxygen, carbon is an ether. What about this right here? Say again? No, don't get tricked by that one. Look at the carbon to the left of it, of the O. How many H's are there? None. So what do you know for sure about that carbon that's in that carbon chain? What do you know for sure about a carbon in a carbon chain? It's got to be connected to a carbon here and a carbon here, or it's not in the chain. So it's got two bonds to carbons, and then since there are no other H's, where are the other bonds? Both to that O. So what is a carbon doubly bonded to an O with C's on both sides? Nope. It's a ketone.
Oh, there it is. There it is. Cool.
And then this, seriously? And then this one here is an alcohol. And then this one here, okay. And I guess maybe you could call these guys benzenes. Okay, we're going to name all of these decanes. So this first one, five propyl decane. And the second one? Five isopropyl decane, because it's 3 carbons, so it's prop. And it's hooked to the middle, so it's iso. 1, 2, 3, 4.
No, it's up to number 6.
No, it's not.
Oh, I counted the wrong way.
Okay.
So then it goes 5. Damn it. They're all 5.
You can't name that. Because the longest chain is 11. Yeah. Let's say I did say that they're all decane molecules. So what would the chain be if it was a decane molecule? 5 pentyl decane?
Yeah.
Okay.
I got it.
And then the next one? This next one here?
Tert.
T or tert, butyl. 1, 2, 3, 4, 5. Yeah, I drew that one wrong too.
Or is it iso?
It's actually isopentyl, but I don't ever remember talking to you guys about isopentyl. So,
That's what I wrote.
1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. Yeah. Sorry, there shouldn't have been, that shouldn't have been there. I should have had that hooked up differently. Actually, that's not what's not supposed to be there. That's not supposed to be there. If that's gone, then it's okay. Complete the reaction of 2-hexene and chlorine gas. 2, 3, 4, 5, 6. Not drawn very well. 2, 3, 4, 5, 6, and 2, and so then we end up with 2, 3, 4, 5, 6, Cl and Cl. Do I need a trans there? Trans for the answer for the name of that one on the right. There's one up, one down, so is it trans? Why not? There's no double bond, so I can't call anything cis or trans. The thing could just flip around and they could be right next to each other. Draw 3 dye-substituted aromatic hydrocarbons and name them each twice. Okay. So- Something like that. Just throw benzenes up, toss a couple of things on them. So let's say for this first one up here, we could call this O-methyl phenol. Or we could call it O-hydroxyl toluene. We could call this next one parafluorotoluene. Or we could say 1-fluoro-4-methyl benzene. We could do, for this last one, meta-amino styrene. Or we could do, let's say 3-amino styrene. So remember, there's lots of different ways that we could name the aromatic hydrocarbons. And that's it.